Hi, everyone. Thank you for coming to our session today. I'm Srini Venkataramani. I'm a product manager at Samsung Next. Samsung Next is focused on creating software and service businesses at scale. At Project Whare, we've been working on a cloud service for spatial computing. And as you know, one of the most exciting applications of spatial computing is augmented reality. So today, we're very excited to share with you a first look at our augmented reality platform that allows developers to create cross-platform, multi-user, and persistent AR applications. So as a developer, this allows your users to interact with 3D content in physical spaces, both co-located and remotely at low latencies. It also allows them to look at content persistently between sessions and users. We believe this opens a range of applications for consumers and for enterprise, things such as games and social apps, indoor navigation apps, industrial design, education and training, and more. We're offering this currently as a Unity package that supports both ARCore and ARKit. So it works on your iOS devices and on your Android devices. Let me introduce you to Jayashree, who's going to walk us through the process of creating an app using Project Whare. She's going to take existing game logic and AR enable it within this session. Jayashree?
Thank you, Srini, for the introduction. Hello, everyone. My name is Jayashree Nagarajan, and I'm an SDK engineer in the AR cloud team in Project Whare at Samsung Next. And my background is in augmented reality and game development. And I'm very excited to be here sharing with you some of the challenges we are trying to solve in the space of augmented reality and spatial computing with Project Whare. So this is a technical workshop, as you all know, and I want to spend the next 20, 25 minutes showing you how easy it is to build a collaborative, multiplayer, persistent AR experience in Unity with Project Whare. And for the demo today, I have decided to build a simple blocks game where players collaborate and build structures with simple, colorful blocks. And the game will allow users to tap on any side of any block, to snap on a new block, thereby engaging in dynamic block building, building sculptures. The video that you're watching right now is a working version of the demo that we have built, and a version of it is what we are going to build together in the next few minutes. And if you haven't checked out the demo already, please come out after the session, and I encourage you to come check us out at the booth for playing with us. So let me quickly jump into my development environment. OK, so I have my Unity environment open. For those of you who aren't necessarily familiar with Unity, let me just give you a quick rundown. Unity is an authoring tool primarily used in game development. So a lot of it is done with drag and drop, where you're configuring things in the scene with what's known as the inspector that exposes various properties and options to apply settings to the game objects in the scene. And the way you customize behavior of these game objects in the scene is often by writing scripts and attaching them as components. And so as you can see, I have already imported the Whare package into an empty Unity project. And I also brought in the scripts that I wrote for the dynamics of the blocks building game. And I also pre-configured my player settings to make sure that it runs fine on my Android device. And setting up a Unity environment just took a few minutes, but I don't want to bore you with details here. So let's get started. Before that, for the entire development process, I tried to break down into three different stages. First, I want to show you how to set up the scene from scratch and touch upon a few key components that are going to be more important for building any sort of AR cloud-enabled app. And then we'll talk about what virtual spaces are in our context and what virtual objects are and how we can go about creating a virtual space, add, retrieve virtual objects, and even process them in the sessions. And then finally, we'll briefly touch upon what localization means, and specifically point cloud localization, and how you can easily adapt your existing app to localize to a point cloud. So let's get started. So I'm going to start with a new scene. And the first thing I want to do is delete the main camera and drag in the AR camera prefab that I can find under Whare prefabs folder. The AR camera prefab takes care of all of the AR functionalities under the hood, such as creating and managing AR sessions, localization, rendering camera feed as a background, etc. Note that if you're used to using your own AR functionalities, then make sure to add the prefab associated with those instead of this one. And the next thing I'll do is drag the Whare Manager prefab into the scene. Whare Manager is the main entry point to accessing any Whare functionalities. And this is the main sort of a gateway to accessing, like if you want to create virtual space or download virtual objects, this is the main entry point for doing any of that. And as you can see, the inspector for the Whare Manager exposes a few different properties. And I want to highlight on two important ones. The first is a reference to the Whare config file. And this is where you would be providing your app credentials that you will receive when you first sign up for the SDK. I went ahead and filled mine. This is important to authenticate your app, and that's the first necessary first step to accessing any Whare functionality. So make sure you do that. And the second is a reference to a list of Whare object prefabs. Now, what are Whare object really? Whare objects are essentially game objects in the scene that are also cloud aware. That means these objects can persist across different app sessions and are capable of being interacted with in a multiplayer setting. And you can make any game object into a Whare object by attaching the Whare object component to it. And there is an associated virtual object that gets created in the Whare cloud that contains all the information needed to that is going to be needed to restore the state of the game objects in the scene when you enter the virtual space, such as position, orientation, name, description, or any local information that you want to store in the cloud. That all will be in the virtual object. And Whare Manager needs to know which prefabs that you want in your virtual space, a reference to those, so that it knows when you connect to a virtual space and Whare Manager finds all the virtual objects, it knows exactly which prefabs to instantiate corresponding to the virtual object that it finds. And I already configured my prefab to be a Whare object. I'm just going to drag that here quickly and show you what it looks like. This is just a simple default Unity block that I created, and just with a fancier mesh. And the only customization I had to do is attach the Whare object component right here. And this is a Whare object now. So I'm just going to delete that and give that as a reference to the Whare object over here. All right, so this was, so far we set up our scene. Just a quick recap. We set up with AR camera, Whare Manager, and we configured our game object to be a Whare object, and then told Whare Manager about the reference, so it knows what to instantiate. The next thing would be to create a virtual space. So let's create that. So before that, I want to talk a little bit about virtual space. So virtual space is really a self-contained environment that can overlay digital information on top of a real-world space. And every virtual space is tied to an actual physical location. And you can have any number of virtual spaces for a specific location. And there are basically 2 steps to creating a virtual space in Unity with Whare package. First is authentication. So when you authenticate with your app credentials, and once your app is successfully authenticated, Whare Manager will return you with a list of virtual spaces that you could potentially connect to. So, and you can either pick one of those and connect, or you can create one, which is what we're going to do right now, and then connect. And when you try to connect, Whare Manager tries to calibrate your virtual space depending on where your app is localized. Now, what is localization? In plain, simple terms, localization really means aligning your virtual camera to what the real camera sees. That means, let's say you have configured your virtual camera to see some of the digital content in the scene. And what localization does is accurately estimate the position of the virtual camera so that it can align well with the device camera. So it looks as if the virtual content is in the real world. And there are several mechanisms. For localization to work, there's a certain level of understanding that your app needs to have about your environment you're in. And there are several mechanisms that can help understand the environment. For example, these are some of the very common mechanisms people have used in the past, starting from fiducial markers, which are sort of old school way of understanding the environment, or bridging the digital world to the real world. And 2D markers are very similar, but sort of provides a richer set of feature points to localize your environment. And point clouds are much more complex mechanisms, but gives you more freedom to localize anywhere without having to depend on any markers like image targets or fiducial markers. And we will see in the end how you can quickly localize to point cloud. Okay, so enough of the literature. Let's jump into Unity and code some stuff. So how do we create a virtual space? We provide 2 main utilities components that you can that does a lot of these steps for you. So you don't have to worry about writing a whole bunch of boilerplate code, at least when you're getting started. And that's localization module and connection module. So I'm going to add those modules here. The localization module takes care of localizing to either image or point cloud. I'm going to leave it to none for now, in which case it will manually calibrate to relative to the camera position. And then the connection module. Connection module takes care of all of the Whare functionalities for you, such as creating virtual space, authentication, loading virtual objects, things like that. And here, and creating a virtual space is just one single step. I'm just gonna give it a name here. I'm gonna call it SDC Hall. And connection module will, under the hood, try to authenticate your app with the Whare config, with the config information that you already provided here, and then create a virtual space for you. At this point, so we have already, if you run the app right now, you would see that we are already successfully authenticated and enter the virtual space, but there isn't anything that we have built to really experience the virtual space. So let's add some functionality to create some virtual objects in the space that we can interact with. So you can actually see things happening in there. So I'm going to write show you some code on how to add and delete virtual objects in the virtual space, and then build some UI to hook the methods so we can invoke them. So quickly going to Visual Studio. So here's my methods. So this is the add block method where I'm just calling where manager.create where object, and I'm passing in the prefab that I want to instantiate with a position and a rotation for it to be created there, and then a brief description. And this is block created is an optional callback. Can you all see my pointer? Okay. This is an optional callback that where you can handle a lot of customizations that you might want to do. You can add some changing colors or adding sounds or any in-app logic that you want to do once the where object gets created. So you can do that in this callback, which we'll see in a minute. For now, I'm just going to print out a simple log message. And then clear objects is a very similar thing. I'm just looping over all the where objects and calling on where manager.delete where object. As simple as that. I also created an input manager for this app. It's to detect user input and give me, just to detect what side of the block player tapped on, and gives you back a position and a rotation. So, and then it gives as a callback. And then I'm just subscribing to that callback over here, and on tabbed, it's going to create a where object at that position and rotation. So let's build some UI in Unity and hook these methods. I already created a basic canvas with basic buttons in here. Just a connect button, add block, and a clear block, just to save some time here. And I also need an empty game object to, to drive the, this is going to be my game controller that'll drive the behavior of this app. And I'm going to attach game controller script, which I just walked you through, as a component. And I'm going to give it the block prefab as a reference. And let me quickly wire these buttons. So first thing is, this is my connect button. I'm going to tell it to invoke connection module.connect. This will under the hood authenticate you and then connect you to the virtual space. And then in the virtual space UI, I will call game controller dot add block, and delete is very similar. Game controller dot clear block, clear objects. And I think there's one more step. So if you notice, localization module and connection module are expecting some UI for displaying error messages. So where manager can give you some useful log messages that could be very useful for debugging. So I just put out some text here to display those. And let me quickly link those up here. And then there's a start button, and then the virtual space UI. Okay, so let's see what happens. So I'm hitting play. Okay, one more step, actually I forgot, is I need event system, because I have a canvas and you need an event system to interact with the canvas UI. So let's try again. I'm going to click on connect, and it's loading, trying to load, and there you are. So once the virtual space is created and it successfully connects, you're now seeing the UI associated with the virtual space. Let's click on add block and see what happens. So it created a block for you. And let's say I exit out and then come back again. You should expect the block in the cloud. So when you next time connect to the virtual space, you should find it here. So it was not just local, and that was just persistence out of the box. So I did not have to write any code to manage my persistence, right? I did not have to implement my cloud. All of that comes with the Whare package. Let's try to interact with these blocks. Remember, I wrote an input manager script that can detect input on the blocks. So I'll just add that component so that it can detect. And then I also wrote a camera move script, which is not really required, but this is for easy editor testing, so I can move around with my keys. So let's enter the space again. And okay, so let me click on that block, and so there are a few blocks getting created, and then if I click on clear all, it gets deleted. So this is the basic, basic functionalities, like basic game interactions are already built in. There's one more thing I want to do though is process these Whare objects while I'm in the space. For example, let's say I want to randomize the color of these blocks. Remember, I told you about this optional block created callback, and this is where you could do that. So this gets invoked after the Whare manager instantiates the prefab in your scene, and a virtual object is created in the cloud. So I'm just going to uncomment this one and quickly go over that. So all I'm doing here is, so I have a list of colors here, and just picking a random color and adding that as applying that as a material to the Whare object, and then adding that information as a meta information to the block. So that information will be stored in the cloud. So next time when it gets processed, we can retrieve those information and restore that information. So the way you do that is with this callback, Whare object become available callback. And let me quickly uncomment that, and I'll go over that. So the Whare objects become available callback gets invoked when you first enter the virtual space, or some other player or user have created an object while you are already in the space. So what I'm doing here is for each of I'm just looping over the virtual Whare objects, and then subscribing to the meta updated event. And in my block updated handler, just retrieving that meta information of color and applying that color back. So let's see that in action, and that'll make more sense. So in my game controller, I'll just pick 2 colors for now. So a green, something like that. Okay, maybe not red, to distinguish between the default ones. Okay, so let's see. So I'm going into my virtual space. Since we already created the virtual space, it's going to connect to that and not create a new one. So let me add a block now. Okay. Okay, so it has a green color, so let me just add a few more. And then what we are trying to test here is to see whether these properties do persist, or is it just something local that's happening. So let's say I have like few different blocks here with green and blue, right? So I exit my space and come back again, and you should see those blocks in the same exact positions with same exact colors. And this was just an example. You could associate any customizations you may want to have depending on what you're building with this. So again, quick little recap on this one. So so far we set up the virtual space with a name. So this is where you would, in the connection module, you provide a unique virtual space name, and it creates one for you, and then write a few snippets of code for create virtual object or delete virtual object, and then invoke those, and then the next important thing that you want to remember is subscribe to the project, the where objects become available callback to do any local customizations to your where objects in your space. And that's all there is to building a basic interactive application with Cloud Enable. One last thing I do want to mention is how to adapt this app to localize to a point cloud. And that's a really simple step. I'm just pick point cloud from here, and the point cloud process goes through different stages. So if you don't have a point cloud already associated with the virtual space, you can initiate a capture process, and then stop the capture process. And once the feature points are good enough, and it creates, you can stop the capture process, and that point cloud will be available for that virtual space. And so the next time you come back in, you can either connect to it or you can create a new one. So the localization module just exposes a few different UI here for capture, stop, reinitialize, and relocalize. And so that's it's hard to show that in the editor, but the demo that we have built that's actually showcased in the booth is using point cloud capture. And this is exactly the steps that we had to take to make it work with point clouds. And I think that's all there is to it. I think one thing I do want to mention, is, the most exciting part for me was, when I went through the app building process, I did not have to think about building my own cloud or networking logic for bringing the multiplayer experience. All of that is built into Whare, so I can focus on my game mechanic, and I can even adapt any AR app to become cloud-enabled just in a few minutes. All I need to do is set up a few things in the scene, and with a very few lines of code, I can just enable AR cloud in a few minutes. So this was a really exciting journey for me, and I really hope you guys are equally inspired, if not more, and I would love to see what you guys come up with, and want to see more possibilities in the app building process in the spatial computing. Please visit our landing page. This is this is where you can sign up for our private beta. And let us know. Our team is here at the booth, and if you haven't already stopped by, please stop by and get a sneak peek of what we have built. And any questions you may have, we are happy to answer that. So, quick little housekeeping. Those of you who haven't filled out the survey, please do so, so I get invited next time. We are also, we are also announcing the winner in the next few minutes. So this is your last chance to fill out the survey. And we'll just hang around here for a few minutes and then make an announcement right here. Hope you enjoyed this workshop. Thank you so much.